Hey guys, number 66 coming up. Okay, so this is asking for a horizontal tangent. So again, you should be looking for where derivative is 0. And this little piece right here tells you only look within one loop of the unit circle. Include 0 in your answer or in your possible answers, but don't include the 2 pi. All right, so I'm going to find the derivative. One of the things you might have been confused about is right here, that square root is only on the 3, not the x. So this is just a coefficient right here. So the derivative is just the square root of 3. Then the derivative of this guy would be negative 2 sine x. And now we set it equal to 0. Okay, so solve that, subtract root 3, and divide by negative 2. And you get sine of x equals, subtract root 3, divide by negative 2, and we're looking for when does sine equal positive root 3 over 2. So in your unit circle, when does sine equal positive root 3 over 2? So think about your unit circle. Is this a spot where sine equals square root of 3 over 2? No, because remember it's cosine sine. So now you know it's one of these guys, and we're looking for where sine is positive. So that's going to be, remember, we go left and right the x and up and down the y. So left and right cosine, up and down sine. So it's these two places right here. So on my unit circle, I now need to figure out what is the name of this spot and this spot. So remember, we count by 6. 1, 6, 2, 6. This is pi over 3. Okay, doing that again. 1, 6, 2, 6, 3, 6, 4, 6. That's 2 pi over 3. Okay, and those are the two places within this domain where there is a horizontal tangent. And you could graph this and check that. So normally, honestly, that's the end. They usually just want the x coordinate. But remember, for these problems, they're asking for the coordinates of the points. So you now know your x coordinate. You have one at pi over 3. And you have another one at 2 pi over 3. And to get the y coordinate, you got to plug those numbers in to the original function back up here. And you'll get possibly a weird answer. So if I plug in pi over 3 right here, okay, you're going to get the square root of 3 pi over 3. But if I plug in the pi over 3 right here, you have to figure out back on your unit circle, what is the cosine of pi over 3? So I shouldn't have erased that. But back over here at pi over 3, where that answer was, these numbers would have gone 1/2 and square root of 3 over 2. So the cosine there is 1/2. So this would be 2 times 1/2, which is 1. And that's the y coordinate of that crazy point. Now do the same thing with the other point. At 2 pi over 3, if I plug this point in now, this becomes a 2 pi over 3. Multiply straight across, you're going to get 2 root 3 over 3 pi. And if I do the 2 pi over 3 right here, I need the cosine of 2 pi over 3, which is here, and that's going to be negative 1/2 times 2 is negative 1. So that's how I wrote my answers. Now I'd have to check the solutions manual. Sometimes when you have fractions like this, they could have also written that with a common denominator. So both of these, this 1 right here, could have also be rewritten as 3 over 3. And if you visualize that, another possible answer, if that was a 3 over 3, rewriting this with a common denominator would have been a 3 on the bottom, and then across the top, square root of 3 pi plus 3. That's another possible way to write the y coordinate. Now, to be honest, the most important part of this problem is, could you get this far? If so, that's probably all you would be asked in this one. Okay, hope that helped. Bye.